Welcome students. In previous lecture, we studied various atomic models and their drawbacks. In this section, we will discuss atomic number, mass number, and isotopes, isobars, and isotones. With the discovery of the neutron, Rutherford was led to modify his views about the nucleus. The positively charged minute central part of the atom is called nucleus. It contains neutrons and protons. The mass of the nucleus is virtually the mass of the atom, and the mass of the atom is due to presence of protons and neutrons in the atom. The sum of the number of protons and neutrons is called mass number. Nucleoside is surrounded by electrons that move around the nucleus with a greater speed in circular path called orbit. Electrons and the nucleus are held together by electrostatic force of attraction. Atomic number is the number of protons in an atom, or in a simple way you can say that it is equal to the number of protons in the nucleus of the atom of the element. In order to keep the electrical neutrality, the number of electrons in an atom is equal to the number of protons, and it is designated as Z. An atomic number is equal to number of protons in the nucleus of the atom, and mass number that is designated as A, and it is the sum of number of protons plus sum of the protons plus the number of neutrons. Protons and neutrons present in the nucleus are collectively known as nucleons. Students, do you know about net charge? Net charge describes how the protons and electrons balance out. Suppose if contains 3 electrons and 3 protons, then what would be the net charge? Net charge would be 0. That means the species is neutral. And suppose if it contains 3 electrons and 5 protons, then what would be the net charge? It would be plus 2. That means the species would be ion. Similarly, if it contains 5 electrons and 3 protons, then the net charge will be minus 2. Mass number is equal to sum of the number of protons and neutrons. Here you can see the example of hydrogen, helium and lithium. The number of protons in hydrogen nucleus is 1, and in helium atom number of protons is equal to 2, and number of neutrons is equal to 2, and number of electrons will be 2. In the case of lithium, it contains 3 protons and 3 electrons and 4 neutrons. Let us now move on to the numericals of this part. Calculate the number of protons, neutrons and electrons in bromine. Atomic number of bromine is equal to 35 and mass number is 80. Atomic number is equal to number of protons is equal to number of electrons, that is 35, and mass number is equal to 80, and in this way we can calculate number of neutron. 80 mass number minus atomic number, that is 80 minus 35, that is 45, and species is neutral. In second numerical, the number of protons, electrons and neutrons in a species are equal to 16, 18 and 16 respectively, and assign the proper symbol of the species. Students, before using the notation, make it sure whether the species is a neutral atom, cation or anion. If it is a neutral atom, number of protons will be equal to the number of electron. And if the species is an anion, determine whether the number of protons are larger or smaller than the number of electrons. In this case, atomic number is equal to number of proton, that is 16. Means the element will be sulfur. And atomic mass number is equal to 32. And the species will be iron, that is sulfide iron. Isotopes are the atoms of same element having the same atomic number but different mass number. The composition of any atom can be represented by using the normal element X with superscript on the left hand side as the atomic masses number A and subscript Z on the left hand side as the atomic number. The difference between the isotopes is due to presence of different number of neutrons present in the nucleus. Hydrogen contains 3 isotopes. 99.9% of the hydrogen atom contains only 1 proton, and this isotope is called protium. Rest of the percentage of hydrogen contain 2 other isotopes such as deuterium and tritium, which contains 1 proton and 1 neutron, and tritium contains 1 proton and 2 neutron. It is found in trace amount on the earth. All the isotopes of the element show same chemical properties because chemical properties of the atoms are controlled by the number of electrons. Here there are some rules that are connected with the structure and stability. Elements with even number charges are more abundant, more stable and richer in isotopes. Nuclei containing even number of neutrons are more stable than those with odd number of neutrons. Elements with odd atomic numbers have only 1 or 2 stable isotopes. Isobars are the atoms of different elements having the same mass number but different atomic number. The atoms of isobars contain different number of electrons, protons and neutrons, and their chemical properties are different. Argon, potassium and calcium, these are the example of isobars. Here you can see the diagram of argon, potassium and calcium. Isotones are the atoms having the same number of neutrons but different mass number, and they have different physical and chemical properties. Silicon and sulfur are the example of isotopes. All these contain equal number of neutrons, that is 16. The atomic number of silicon is 14 and mass number is 30, whereas atomic number of sulfur is 16 and mass number is 32, and the number of neutrons would be 16. In this way, you can calculate the numericals related to atomic number, mass number, and isotopes also. In next slide, we will discuss about wave mechanical theory and quantum theory. Thank you.